Hi.
All right. Can you see and hear my? Can you see me and hear me?
Yeah.
Okay. All right. So today's lesson, we're gonna go over. So we're gonna try to go over three things: linear equations in two variables, plotting ordered pairs, and graphing linear equations because they're all related, basically,
Yeah.
and they're pretty easy to learn. So, okay. Did you have any trouble on the previous assignments?
No.
No. Okay. All right. So now we're in case you're curious, we're in section 2. So section 2, so this is the curriculum for Algebra 1. Section 2 covers these things. Linear equations in two variables. Okay, let's go ahead and start. So linear equations in two variables come in the following form. So here we have ax and bx equals c, where x is a variable and y is a variable. Okay, we have two variables now instead of what we did before, which was equations in the form ax plus b equals c. Okay, we have two unknowns. And the type of problems that you're going to be dealing with are like the following, where we have an equation and it says, what are some of the possible solutions to the following equation? So we have 3x plus 5y equals 21. Now, one way to find out some possible solutions. So the solutions to this equation would be whatever values of x and y are, okay, the ordered pairs for x and y that make this equation true. And one way to find this out is to simply try plugging in some values for either x or y and solving for the remaining variable. Okay, so if you were to plug in x equals, for example, 2, okay, then we would have 3 times 2 plus 5y equals 21, or 6 plus 5y, 21. If you subtract 6 from both sides, you get 5y equals 15, and y is going to equal 3. So one solution, one ordered pair solution for this equation is 2 and 3. And can you think of another set of ordered pairs that would make the equation true?
Yeah.
Which are?
Um.
So one easy way that you can use to create solutions easily is to simply plug in 0 for one of them. So the equation we're dealing with is 3x plus 5y equals 21. If you were to plug in a 0, for example, for 5, well, that would just go away, right? Because 5 times 0 is 0.
Yeah.
And so we would just be left with 3x equals 21. If you divide both sides by 3, you get
7.
7. So another possible solution to this equation is 0 and 7. Okay, and you could do that using any. So you could have plugged in a 1 for 2 for x. You could have plugged in 3. There's actually an infinite number of solutions to this equation. And the reason why that's true, can you guess as to why there would be an infinite number of solutions to the equation? So, what was the... Sorry, what was... Do you remember what the equation was? Was it 2x plus 3y equals 21? Yeah.
Yeah.
2x plus 3y equals 21. So this is Desmos. You can simply just... It's a graphing calculator website. Very, very useful, especially for algebra. I've written 2x plus 3y equals 21. It's an equation for a line. 2x plus 3 equals 21 is an equation for a line. And what it gives us is this graph. And what does each point represent on this line?
A possible solution.
Exactly. Every point on this line is basically a solution to this equation. If the equation for the line is 2x plus 3y equals 21, then every single value of xy that you see here on this line will be true for this equation, right? This equation, 2x plus 3y equals 21. And you can see we can verify because one of the solutions was 0 and 7. Well, here, look, we have 0. And at 0, we have 7 for the value of y. The other was what? The other was 2 and 3. So, how do I get rid of this? 2 and 3. So, at 2 and 3... that's not showing up. Hold on.
I think the equation was 2x plus 5y.
Okay. Thank you. 2x plus 5y equals 21. So at 0, so hold on. I think I made a mistake. So
it's 3x, not 2x.
3x plus 5y. So I made an error for the other example, this one. So it's when y is 0, x is 7.
Okay.
So the possible solutions that we've come up with are 2 and 3 and 7, 0. And the equation is actually 3x plus 5y equals 21. 3x... So as you can see, the solution that you got was 7, 0. And look how it's on the line. 7. So I can type in 7, 0. And that's on the line. The other was what? 2 and 3?
Yeah.
And that's on the line as well. And what's unique about these two solutions is that they're integer solutions. In other words, they're not things like fractions. But fractions are completely okay. So, let's see, 3. So I think this would be a fraction. Yeah. So at 3, if x was 3, what would 21 be? 12. So if x is 3, so it would be something like 2.4. So fractions or decimals are okay. Usually we write our answers in decimals as well. But one thing you want to do is try to get integer solutions.
Yeah.
So that's what I mean when I say there's an infinite number of solutions. Let's try another example. Determine if the ordered pairs are solutions to the following equation. Before you start, actually, how would you solve this? How would you verify that -3 and 2 is an actual solution to this equation?
I plug it in.
And see if you get a true statement.
Yeah.
Yeah. So go ahead and do that for A, B, and C, and let me know when you're done.
I'm done.
Okay. So what was A?
A is false. It's my answer was 14 equals 10, and that's not true. So it's not A.
Okay, so A is false. What about B?
B is true because I got 8 plus 2, which is 10, and 10 equals 10. And C is also true because the negative 4x cancels out and 10 equals 10.
Yeah, good. Okay. Let's try the next example. It says determine if the ordered pairs are so same thing. Let's just do it quickly because so A 3 and 1. So if I do that, you get 9 minus 12 times 1 is 12 equals negative 3. So 9 minus negative 12 is negative 3. Negative 3 equals negative 3. So therefore this is true. What about 4 and negative 2?
Oh, 12 minus. That's false. B
Yeah.
is false.
Yeah. So what happens is if you plug in 4 and negative 2, you get 12
Then you
minus,
yeah.
sorry, minus a negative 24 equals negative 3. On the left, you have 12 plus 24. That's 36. So 36 does not equal negative 3. Therefore, that's false. And 1 and 0. So you can just cross that out. 3 times 1 is 3. 3 does not equal negative 3. Therefore, C is false as well. Okay.
Yeah.
All right. So creating a table of solutions of ordered pairs. So this is very important because a lot of times in algebra, we're going to be required to ask, we're going to be asked to graph a line given some equation. And one of the ways you can do that is by creating a table. Now, there's other more efficient ways to do it. For example, using the slope intercept formula, which we're going to learn in, I think, our next lesson. That's a lot easier to create a graph. But the other way, in case you didn't know about the slope intercept formula, would be to simply create a table. So here, we're asked to create a table of solutions for the following equation. We have 2x minus 5y equals 10. And an effective way to just get the first 2 points of any equation is to use the intercept method. And that's when you plug in zeros for each one of these and solve for the other. So as a reminder, what is the y-intercept? Well, it's when x equals 0. Okay. In other words, if you were to plug in 0 for x into this equation, you would get your y-intercept. If you were to plug in 0 for y, you would get the x-intercept. And if you think about it, there's only 2 points that you need on a graph to create a single line. So if you had the y-intercept and the x-intercept and you just connected the points, you would have your line. So let's do that real quick. So the first 2 points, so a table, I'm going to create a table. And I'm going to plug in a 0 for x. So if I were to do that, I would get a y value of negative 2. Because 2 times 0 is 0. And I would have negative 5y equals 10. And y would equal negative 2. And then I'm going to plug in a 0 for y. And if I were to do that, I would be left with 2x equals 10 and x would equal 5, right? 2 times 5 equals 10. So there's my 2 points. Sometimes, though, what you want to do is, for a little bit, for completeness, you might want a third point, okay? Or a fourth point or a fifth point, just if you want it to be more accurate than just simply having 2 points. To get a third point, what I would do is just plug in any number for either one and solve for the other. So let's try something that I think would give us an integer solution instead of a fraction. Let's try. Hmm. So 3. Let's try 5. So if x were to equal 5.
Isn't
Oh,
that
weird.
already a
Yeah.
variable?
Yeah, weird did it. Um, can you think of any? I can't think of any. So I'm trying to avoid getting
Uh,
a
2. Wait, no, not 2.
3, 6. I can't figure. Hold up.
No.
Let me try graphing this line. 2x minus 5y equals 10. So here is our two intercepts, 0, -2, and 5, 0. And I'm trying to look for an integer solution. So
6 and actually, never mind.
huh. How about this one? Oh wait. -5? -5 for x. Let's try -5 for x. If we do that, we get -10 minus 5y equals 10. We're going to add 10 to both sides. We get -5 equals 20. Divide both sides by -5, and we get a y value.
-4.
Yeah. So then we have 3 points, and this would be very useful for graphing. Okay.
Yeah.
By the way, if so, what happens if we plug in, for example, 1? If we were to extend this table, just to show you that fractions are okay as solutions. So if I do x equals 1, then we would have 2 minus 5y equals 10. If I subtract 2 from both sides, I get -5y equals 8. And if I divide both sides by -5, I would get a y value of -8 divided by 5. And that would be okay. That would be, it's just a fraction, that's it. But it's still a solution of the equation.
Yeah.
Okay? All right. Okay. You can try this one. Create a table of at least 3 ordered pairs for the following equation. So create a table and let me know when you're done. And again, you get the first 2 points by plugging in zeros for x and y and solving for the other variable. Are we close to being done?
Yeah.
Okay. So what did you get?
Uh, 0 and -4. 2 and 2. and negative 4 over 3 and 0.
So if y equals 0, yeah, that's correct. Okay. What happens if y is negative 1? So, okay. Okay, so that's it. That's it for linear equations in two variables. This was like an introduction to the concept of linear equations in two variables. Let's move on to plotting ordered pairs. Another very easy topic. And the first thing you need to do is know or remember or memorize all the parts of a Cartesian coordinate plane. So it's something that looks like this. It's used to basically graph equations. You can graph things like points and lines and figures, but it's mainly used to graph equations and functions to see what they look like visually. There's two axes. This is the x-axis. It controls the movement horizontally, left and right, and the y-axis, which controls the movement up and down vertically. Okay. There's four quadrants. Quadrant 1. So the quadrants are written in usually in Roman numerals. So this is Q stands for quadrant, and this is 1. Okay, quadrant 1. Quadrant 2. Quadrant 3. And quadrant 4. So it's labeled counterclockwise. So it goes in the opposite direction that a clock would.
Yeah.
And we label, there's also the idea of positive and negative numbers. So the first quadrant is always positive and positive, meaning the x value is positive and the value at y value is positive. Okay, the quadrant 2 is going to be where x value is negative and the y value is positive. And quadrant 3 is when you have both negative values for x and y. And then quadrant 4 is when you have a positive value for x and a negative value for y. Okay, and this should make sense because, so for ordered pairs, when you graph an ordered pair, you do it in order. The first thing you do is you're going to look at x and then you're going to look at y. That's to graph a single point. X is going to tell you whether to go left or right. If it's positive, you go right. If it's negative, you go left. Okay? And then after you've determined that, you do your y value. Well, the y value is going to tell you whether to go up and down, right? Vertical. So if y is positive, you go up. If y is negative, you go down.
Yeah.
So it says to plot 2, 2, 5 on the coordinate plane. So you always want to draw your axes or label them x and y when you do it. And you don't need to be terribly, so you don't need to like do this. You could if you wanted to, but if you look at the ordered pair that we're asked to plot, it's only 2 and 5. So if you just did 2 notches over here and then 5 notches for the y-axis, it would be okay. But what it's telling you is to go right, since it's positive, it's telling you to go right twice, 2 units. And then because the y value is positive, it's telling you to go up 5 units. So if I go right 2 units and up 5 units, I end up here. So that's going to be your answer.
Yeah.
Okay, your turn. Go ahead and plot the ordered pair -4 and -7.
Wait, do you want me to draw a graph?
Yeah. just on a piece of paper or whatever.
I'm done.
Okay, so if you were to do it, it would be something like this. -4 is telling you to go left or right.
Left.
Yeah. So 1, 2, 3, 4. And -7 is telling you to go up or down.
Down.
So I'm going to go 4 left and 7 down. That's our answer.
Yes.
Okay. And what quadrant is it in?
3.
Yeah, quadrant 3. And then try this one. Plot 7 and -3.
I'm done.
Okay. So here's our y. Here's our x. 7 and 3. So that would tell you to go right 7, 4, 5, 6, 7, and then down 3, right? Right?
Yeah.
Yeah. So it's right here. What quadrant is it in?
4.
Quadrant 4. Good. That's it. That's literally it for this. I think, yeah, that's literally it for this lesson. Plotting
Yeah.
ordered pairs, very, very simple. You just have to know all the components that go into making up the coordinate plane. Okay, so next lesson, final one. And it's about graphing linear equations. Graphing linear equations. So we can graph an equation given, a line given by an equation by following the 3 steps. So first thing you're going to do is create a table. We know how to do that, right? We just went over it.
Yeah.
Plot the points. We literally just did that. And all you have to do is connect the points using a line. Okay? Very, very easy stuff. There's a much more efficient way to do this, and that's to use the slope-intercept formula. But that's the next lesson. So we're just going to stick to doing it the old way in this one. It says graph the following equation on the coordinate plane. We have x plus 3y equals 6. So let's go ahead and create a table. We can use the intercept approach by plugging in 0 for x. When we do that, we get a y value of 2, right? So yeah, 3y equals 6, y equals 2. And then a 0 for y. And that would give us an x value of 6. And how about when y equals 1? What would x be if y were to equal 1?
6.
So if,
Wait, no. 3.
yeah, so x would equal 3. So now we have 3 points, which I think is enough to graph a line. So let's do that. 0 and 2. So that's here. 6 and 0. 1, 2, 3, 4, 5, 6. That's here. And 3 and 1. That's here. Then all you have to do is connect the dots. And then since this line goes forever, in each direction, you would draw an arrow to show that. Okay, and there's our line.
Yeah.
Yeah. So let's do another one, and it's your turn. So graph the following equation using the methods that we just used, and let me know when you're done.
I'm done.
Okay, what did you get for your table?
I got 0 and -2, -2 and 0, and 5 and -3.
Yeah, 25 minus 15 is 10. Wait,
Wait, no, I meant 1. Sorry, not what, not 5.
so 1 and -3?
Yeah.
So 5, subtract 5, -15. Yeah, 1 and -3. And for the graph, 0 and -2, -2 and 0,
Oh, yeah, right there.
and then 1 and -3. So something that looks like that. Does your graph look like that?
Yeah.
Okay, good. Let's move on. All right. In this one, it says find the xy intercepts of the following equation. So just to review, what is the x-intercept?
Uh, where the y equals 0,
Yeah. Where's the y-intercept?
where the x equals 0.
Yeah. And you can figure out, so you can understand this intuitively by looking at any linear graph and realizing that, for example, look at this point right here. So I've labeled 0, -2. When you can see that you get -2 when x is 0, right? You have -2 here, and if you go up to the x-intercept, it's 0. Therefore, this is the y-intercept. Okay, the
Yeah.
y-intercept occurs where x is 0. Think in kind of like in the reverse. So the other one was what? It was 5, 5 and 0.
Yeah.
So for this one, it was 5 and 0. And where does 5 occur? Well, if you
At
looked,
0.
yeah, it occurs where y is 0. If you go all the way to the left, your y-axis, it's 0. Okay? So that's what's happening. Okay. So for this one, if I wanted to find the y-intercept, just plug in a 0 for x or just cross it out. And then you would get a y value of what? What is -20 divided by -5?
4.
4. Good. So our y-intercept would be 0 and 4. And to consider the x-intercept, you would just cross out the -fy and just consider 4x -20. And if we divide both sides, we get x equals -5. So the y-intercept would be -5 and 0.
Yep.
Okay, all right. Go ahead and do this one and let me know when you are done. Okay, you're finding the x and y intercepts of 7x plus 3y equals 21.
I'm done.
Okay, so what is the x-intercept?
3.
So 3. So 3, 0, okay. And what is the y-intercept?
7, 0, or 0, 7.
Yeah. Okay, good. Yep. So you plug in, for the x-intercept, you plug in 0 for this one. And for the y-intercept, you plug in 0 for this one.
Yep.
All right, the final thing we need to understand are the concepts of vertical and horizontal lines. Okay, so if you were asked to graph x equals -5, it would look like basically a vertical line. So here's, sorry, -5. 1, 2, 3, 4, 5. Right here is where -5 is. And since there's no y, it's a straight line. Vertical straight line going up and down.
Yep.
Okay, that this is saying that for any value of y, x will always be -5. That's what that is saying. So if x equals -5 is a vertical line, what would y equals 4 be?
A horizontal line.
Yeah, a horizontal line. So here we have 4, and it's a horizontal line, just going straight west to east or east to west. And it's saying that for every value of x, y will always be +4. Okay?
Yeah.
Yeah. So just something to remember. Sometimes it's tricky to remember, but there's questions on this all the time. So that's it for today's lesson. Your homework is this. These three. So linear equations in two variables, plotting ordered pairs, and then graphing linear equations.
I think I already did the first two.
Good. Okay. So graphing linear equations.
Okay.
Okay. All right. Thank you.
Bye.
Bye bye.